Let's see something about mobile telecommunication system. For that we should have some knowledge about the cellular systems. So first let's see about cellular systems. The cellular systems for the mobile communication implement the SDM, that is space division multiplexing. Each transmitter, typically it is called as base station, it covers a certain area that is called a cell. The cell radii can vary from tens of meters in the case of buildings and hundreds of meters in the case of cities, up to tens of kilometers in the countryside. The shape of the cells are never perfect circles or hexagons as shown in the figure, that is this figure, it is shown as the cell shape is hexagon. It is not so perfect as shown in the figure. Okay. It depends upon the environment, that is if it is in the building it varies accordingly. If it is a mountain, the shape varies accordingly. If it is the valleys, the shape of the cell varies according to that. And on the weather conditions also it varies, and sometimes even on the basis of the system load. So, the typical systems using this approach are the mobile telecommunication systems, where a mobile station within the cell around a base station communicates with this base station and vice versa. So, this is the cell. It shows the cellular system with 3 and 7 cell clusters. Okay. Cluster is nothing but the collection of the cells. So, we have some advantages and disadvantages. The advantages of the cellular systems with the small cells are higher capacity, less transmission power, local interference, robustness. And in the case of the small cells have some disadvantages, that is infrastructure, handover and frequency planning. So, let us see the advantages in brief. First advantage is higher capacity. So, implementing the space division multiplexing allows the frequency reuse. If one transmitter is far away from the another, that is it is outside the interference range, it can reuse the same frequency. As most mobile phone systems assign the frequencies to certain users, this frequency is blocked for other users. Okay. So, but the frequencies are a scarce resource and the number of concurrent users per cell is very limited. So, the huge cells does not allow for more users. On the contrary, they are to less than possible users per 2 kilometers. So, this is the only reason for using very small cells in cities where many more people use mobile phones. The next advantage is less transmission power. So, power is a major strategy here. So, while power aspects are not a big problem for base stations, it is indeed a problematic one for the mobile stations. A receiver far away from the base station would need much more transmit power than the current few ones, but energy is a serious problem for the mobile handheld devices. If no power, the handheld devices become waste. Okay. So, then local interference only. Having a long distance between the sender and the receiver results in even more high interference problems. With the small cells, the mobile station and the base station only have a few interference problems or have to deal with the local interference only. Then robustness. The cellular systems are decentralized and so more robust against the failure of single components. Okay. If a single component is failed in the case of a cellular system, it is enough to replace that single component. If one antenna fails, this only influences communication within a small area. If it is a large area, all the signals will be barred. So, that is an advantage of having the cellular system in the smaller area. Okay. Then we have some disadvantages because infrastructure is needed in the case of this cellular system. Cellular systems need a complex infrastructure to connect all the base stations. So, this includes many antennas, switches for call forwarding, location registers to find a mobile station, etc., which makes the whole system quite expensive. Okay. So, that is a disadvantage here. Then handover is needed. So, the mobile station has to perform a handover when changing from cell to another cell. Depending on the cell size and the speed of the movement, this can happen quite often. Then frequency planning. To avoid interference between the transmitters using the same frequencies, the frequencies have to be carefully. So, on the one hand, the interference should be avoided. On the other hand, only a little number of frequencies is available. So, that is frequency planning is a disadvantage here. To avoid interference, the different transmitters within each other's interference range use the fixed division multiplexing. If FDM is combined with the TDM, that is time division multiplexing, the hopping pattern has to be coordinated. Okay. The general goal is never to use the same frequency at the same time with the interference range. So, two possible models to create the cell patterns with the minimal interference are shown in the figure. So, cells are combined in the cluster, that is as shown in the previous diagram, that is a cell cluster diagram. Already we have shown the cell structure is explained in that. Okay. So, cells are combined in clusters. On the left side 3 cells form a cluster, and on the right side we have 7 cells to form a cluster. All cells within the cluster use disjoint sets of frequencies. On the left side, one cell is the cluster uses the set F1, another cell F2, and the third cell is F3. In real life transmission, the pattern will look somewhat different. The hexagonal pattern is chosen as a simple way of illustrating the model. So, this pattern also shows the repetition of the same frequency sets. The transmission power of the sender has to be limited to avoid the interference with the next cell using the same frequencies. To reduce the interference even further, the sectorized antennas can be used. The figure shows the 3 sectored per cells in a cluster with 3 cells. Typically, it makes sense of using the sectorized antennas instead of omnidirectional antennas for the larger cell radii. The fixed assignment of the frequencies to the cell clusters and the cells respectively is not very efficient if the traffic load varies. For instance, if in the case of a heavy load in one cell and a light load in the neighboring cell, it could make sense to borrow frequencies. Okay? So, if a cell has a heavy load and another cell has a low load or less load, we have to borrow from the other cells. Okay. So, the cell is with more traffic can dynamically allot more frequencies. So, this scheme is known as borrowing channel allocation. So, while the first scheme, that is before we have seen that scheme is called as fixed channel allocation, that is FCA. So, this fixed channel allocation is used in the GSM system as it is simpler to use, but it requires some careful traffic analysis before installation. So, the dynamic channel allocation, that is DCA schemes, has been implemented in the DECT. So, in this scheme the frequencies can only be borrowed, but it is also possible to freely assign the frequencies to the cell. With the dynamic assignment of frequencies to cells, the danger of the interference with the cells using the same frequency exists. The borrowed frequency can be blocked in the surrounding cells. So, that is called as dynamic channel allocation. So, this diagram shows the cellular system with 3 cell clusters and 3 sectors per cell. So, it is shown in the 3 dimensions. Okay. The cellular system using the code division multiplexing instead of the frequency division multiplexing, it does not need much elaborate channel allocation schemes and complex frequency planning. Here the users are separated through code they use and not through the frequency, okay, because it is code division multiplexing. The frequency is separated on the the channel is separated on the basis on the code, not the frequency. So, the cell planning faces another problem, that is the cell size depends on the current load. However, the load varies, the cell size also varies. So, accordingly the CDM cells CDM cells, this is commonly called as breathe, said to breathe, that is when it is breathing it may expand and shrink. So, while a cell can cover a large area under a light load, it shrinks if the load increases. So, this is a reason for this growing noise level if more users are in the cell. The higher the noise, the higher the path loss and higher errors. So, finally the mobile stations further away from the base station drop out of the cell. So, we have seen when we are away from the base station, the call gets dropped off. So, that is shown here, and this additional user lets the cell shrink with the result that 2 users drop out of the cell. In a real time scenario, this additional user could request a video stream, that is high bit rate, while the others can use the standard voice communication, that is low bit rate. Okay. So, the cell breathing is shown in the figure. So, this is a base station and all the others are the mobile stations which communicate to the base station. When this mobile station moves out of the base station, there may be weak signal, and because of that it may cause a call drop. Okay, that is shown in the figure. The cells in the outer cell radii may drop out of the call. So, that is cell breathing. Thank you.